Hello everyone, we are still solving problems related to chapter 14, which is fluid mechanics. I'll be solving now problem 53, page 445. This problem says a hypodermic syringe contains a medicine with a density of water. So the density of the medicine is as that of water, is 1000 kilogram per meter cube. The barrel of the syringe has a cross-sectional area A equals 2.5 times 10 to the power minus 5 meters square, and the needle has a cross-sectional area A equals 10 to the power minus 8 meters square. In the absence of a force on the plunger, the pressure everywhere, for sure inside the syringe, is 1 atmosphere. A force F of magnitude 2 Newton acts on the plunger, making medicine squirt horizontally from the needle. Determine the speed of the medicine as it leaves the needle's tip. So we are going to find the speed at a certain point here. Let me call it 2. I will call this point inside 1. Okay, so we are going to find V2. Remember, each time he gives us the areas, I have to make benefit of the continuity equation. First, we have a fluid in motion, so I have to use Bernoulli's equation. Let's try to apply Bernoulli between points 1 and 2. So apply Bernoulli's equation. Bernoulli's equation between 1 and 2. We will get P1 plus half rho V1 squared plus rho G Z1. It's equal to P2 plus half rho V2 squared plus rho G Z2. Okay, so let's write what we have. Z1 is equal to Z2. They are at the same horizontal level. So for sure, rho G Z1 will be cancelled with rho G Z2 because they are equal. P1, it's the pressure inside. Before starting to pushing the plunger, the pressure was P atmospheric. So after pushing the plunger, the pressure is P atmospheric plus the pressure exerted by the one who is pushing the plunger. So P1, it's equal to P atmospheric plus P applied, that I'm applying, applied. It's equal to P atmospheric plus F over A. Why F over A? Because I'm applying a force F on an area big A, so F applied is F on A. P2, because point 2 is subjected to air, then P2 must be equal to P atmospheric. So now I have P1, P2, Z1, Z2, okay, already cancelled. There remains V1 and V2. I'm searching for V2, remember, so V1 is also unknown, so now I have to make benefit from the continuity equation. So from continuity equation, we have A V1, it's equal to small a V2, because the area A, big A, it's at point 1 and the area small a is at point 2. Implies, let me write V1 in terms of V2, it's A over A V2. Now I substitute V1 in the equation of Bernoulli to get an equation simply containing V2, so I can find V2 this way. Let me substitute in Bernoulli's equation, then I will substitute P1, it's P atmospheric plus P applied, or it was F over A, plus half rho V1, I will substitute for A squared over big A squared V2 squared. I'm substituting in Bernoulli, okay? I've removed Z1 and Z2. It's equal to P2 was P atmospheric plus half rho V2 squared. Okay, let's group V2 squared to one side because we are searching for V2. So P atmospheric with P atmospheric will be cancelled. I will group V2 to one side, so I will get F over A, it's equal to half rho I will take half rho V2 squared common into 1 minus A squared over A squared. Okay, we have everything. We have F, we have all numbers. Substitute for your numbers. So V2 is equal to F over, or 2F over A rho 1 minus A squared over A squared. Under the radical, substitute for all numbers, you will get 12.65 meter per second, and this is the answer. Hal, if he's looking for the flow rate, the volume flow rate, I simply multiply A2 by V2 or big A by V1. I have to find V1. I can find V1 from the continuity equation, and V1 equals small a over big A V2. So any question he may ask, I'm able to answer it. Now let's do problem 54, page 446. Figure P14.54 shows a water tank with a valve at the bottom. If this valve is opened, what is the maximum height attained by the water stream coming out of the right side of the tank? Assume that h equals 10 meter, l equals 2 meter, and theta is equal to 30 degrees, and that the cross-sectional area A is very large compared with B. So he gave us that A is very large compared with B. Remember that if I use this information with the continuity equation, this will lead to something very important, that is the speed of A is 0. Okay, the speed of water at point A is 0. Point A, look, it is at the water level of the tank. So remember, each time you, in the question he says that the area is very large compared to a hole, compared to a valve, compared to any other area. So he's meaning that the speed at the large area will be approximately 0. This is proved using the continuity equation. I won't prove it. I've proved it twice, I guess more. So, and I have used it once. So I will use it here directly. So VA here it's 0 because the area of the free surface of the fluid in the tank is very large. So let me try to find the speed at point B. I will apply the Bernoulli's equation between points A and B. After finding the speed at point B, I will try to find the maximum height attained by the water. You all know that if the water is ejected from point B, it will move like a projectile. It will be ejected in the same way as a projectile does. So if I know its initial velocity that it is ejected with at point B, I can guess the maximum height that the water will go during its motion outside the tank. Okay, so let's first find the speed at point B. I will try to apply Bernoulli between points A and B. So apply Bernoulli equation between points A and B. So we will get PA plus half rho VA squared plus rho GZA, it's equal to PB plus half rho VB squared plus rho GZB. Okay, let's find them one by one. PA, it's P atmospheric because it is subjected to air, it's P atmospheric. PB, it's also P atmospheric. So this is A, point on the surface, and this is B. It is at the end of the valve. Okay? So PB is also P atmospheric. VA, بعدكم ذاكرين, it will give me approximately 0. Why? Because using continuity equation راح تطلع معي VA بتساوي الاريا على البي over الاريا على الA VB. الاريا على البي أصغر بكثير من الاريا على الA, so I will get VA approximately 0. I've proved it already. Now let's find ZA and ZB. You can take any level you like and you can change your level each part, it's okay. So I will take ZA he gave us the heights from here, so I will take my reference here. And what's ZB? This is ZB. Where's ZA? It is here is ZA. So ZA, as it's clear, it's H, and ZB, it's equal to L sine theta. So ZB, it's equal to L sine theta. If you look at the triangle, sine theta, it's equal to opposite over hypotenuse, so it's ZB over L. So I will get ZB equals L over sine theta. We are looking for heights. Okay, so this is for, I will erase this information. How to know if it's sine or cosine? You look if the Z is opposite to theta or adjacent. أنا هون عندي theta بوجه Z بوجه theta, so for sure it's sine. It's L sine. It's L sine theta. Anyway, I have found everything. Now I will remove ZV, VA. Here I will remove VA. PA with PB, they will be cancelled because they are, both of them are P atmospheric. I will substitute in the Bernoulli's equation. I will get, implies rho G H. I am substituting for rho G ZA. It's equal to half rho VB squared. Rho G ZB, ZB was rho G L sine theta. Okay, so we will divide by rho, all the equation, divide by rho. I'm searching for VB, and I will write GH minus G L sine theta. Okay, no need for the bracket. It's equal to half VB squared, implies VB squared. It's equal to 2G H minus L sine theta. So I have now to do the radical. VB is equal to radical 2G H minus L sine theta. We have everything. We have L, we have theta, it's 30. We have H, we have everything. So substituting, you will get 13.28 meter per second. Okay, this is the answer. Remember that we were not looking for the speed of water at point B. In contrary, we were looking for the maximum height attained by the water stream coming out of the right side of the tank. So we were looking for the height. We say that after the water is ejected from the valve, it will behave as a projectile. So this is a projectile problem. So projectile problem. Okay, because I don't need time, I will use the time independent equation. This equation says Vy squared minus V0y squared, it's equal to minus 2Gy minus Y0. Okay, so what is V0y squared? V0y squared أو V0 it's VB اللي أنا لقيتها أول شيء. V0y it's equal to V0 times sine theta. What is theta? It's the angle that the projectile was making with the x-axis. I will go up to allow you to see the figure. Okay, so as you can see, this is my x-axis, this is my y-axis. هيدي ال VB بتكون okay, this is VB. It's making an angle theta. So if I project here, I will get VBY, and here I will get, this is VBY and VBX. It can be divided to two components, one sine and one cosine. So I'm only care in this equation, there only appears the sine components. So it's VB sine theta, V0 sine theta, which is VB sine theta, because V0 in the case of pressure is VB, is at point P. What do we know is that at the maximum height, Vy will be equal to 0. So 0 مش على maximum height Vy will be 0, so 0 minus Vb sine theta equals minus 2g y. هلا y0 for us إذا بده هو بالهايت, he did not say anything, بس if he's searching for the height from the ground, يعني هون أنا عم بحكي عن ground, بحط أنا ال y0 sorry من هون, if the height is from this point here, so بحط ال y0 he can't initially zb. وإذا أنا بدي ال y0 don't care about it, I will leave it as delta y. so أنا بهمني من قد عمل قد طلع على الطلوع من بعد ما انطلق من البي, so I will leave it as delta y, it won't matter. Okay, so we will get implies delta y, it's equal, I forgot the square here, it's vb squared sine squared theta over 2g. I will substitute. هاي الدلتا y هي المسافة من بعد ما طلع, يعني قد ايه علوه عن point B. Okay, so you will get vb it's 13.28 squared times sine squared 30 over 2 times 9.8. you will get your answer. You will get 2.25 meter. So the distance from the highest point to point B, I will erase everything. Okay, so assume this is the maximum height, so المسافة من هون لهون هيدي delta y, this is delta y, which is y minus y0. Now I have finished solving problems related to chapter 14. I will solve some problems from previous sessions. These sessions are, I guess they are partial sessions, so I will start with this first session. Okay, it's partial exam 2019-2020. I have chosen to solve problem 3, which is related to fluid mechanics. This problem says the adjacent figure represents a venturi flow tube inclined by an angle theta equals 30 degrees with respect to the horizontal, in which water rho equals 10 to the power 3 kilogram per meter cube flows steadily from bottom to top. A manometer containing oil rho equals 800 kilogram per meter cube is connected to the flow tube. So you can see that we have a manometer, a U-tube from the upper side. So in this case we have to find the pressures of PA and PB using this manometer or this U-tube. The cross-sectional area of the tube at point A is 5 times the cross-section at B, so SA it's equal to 5 SP. The distance between A and B is L equals 1 meter. So you can see that AB or L is equal to 1 meter. This is the given. In part 8 it says the relation between the water flow speed at point A and that at B is, so we have to find a relation between VA and VB. So we think directly of the continuity equation. I will write the answers here. So from continuity equation, continuity equation, we have S of A times V of A, I equals S of B times V of B. S is the area, okay, because he named it as S. We have SA is equal to 5 SB, I will replace it, so 5 SB VB VA is equal to SB VB. SB with SB cancelled. I'm searching for VA, implies VA it's equal to 1 over 5 VB. So the correct answer is D. This is the answer. In the second part it says if the flow speed of water at point B is VB equals 1 meter per second, then the pressure difference between the 2 points A and B is, he's giving me the speed at a certain point and he's asking for the pressure between A and B. دايما طلعوا على الووتر عم يضغط الاويل من جهة الاي اكتر ما عم يضغط الووتر من جهة البي. سو اكيد البريشر للاي اكبر من البريشر للبي. سو بي اي ماينس بي بي is positive. هيدي اول شغلة. اعطاني الفي وقال لي جيب البي اي ماينس بي بي. I will think with Bernoulli's equation. So let's use Bernoulli's equation using Bernoulli's equation between points A and B. We will write PA plus half rho VA squared plus rho GZA. It's equal to PB plus half rho VB squared plus rho GZB. As I have told you, you can take a reference. So I will take my reference passing through A. دايما خد الريفرنس تحت. Okay, you can take your reference here. So passing through A. So بصير أنا معي ZA بهيدي الحالة it's equal to 0. ZB بتصير this is ZB from this reference. This is ZB. So we will get in this case ZB is equal to L sine 30. ليه؟ لأنه أنا معي this distance L and this angle here is 30. So I will get ZB is equal to L sine 30. دايما اللي بوجه 30 بتكون sine L sine 30. So I have ZB, I have ZA. So now I can substitute in the equation. I'm searching for PA minus PB. بعد في عندي ال VA because I have VB, so I have to use the continuity equation in order to find the answer. I don't have enough space because I'm writing with big letters, so I try to write PA minus PB. It's equal to, I will gather everything, so I will get half or aside. Let's write here continuity equation so that I can substitute directly. It gives me that SA VA is equal to SB VB. So I will get as up, nothing changed, so I will get VA it's equal to 1 over 5 VB from the previous equation. I will try to insert it here. So I will substitute for VA. I will get minus half rho 1 over 5 VB squared. I've got half rho VB squared, and I still have plus rho G. ZB is L sine 30. Okay, I have everything. I have VB squared, I have rho which is 1000, I have rho G. G is 10. The G in this case is given to be 10 meter per second squared, or 10 Newton per kilogram in SI unit. So we have everything. We have L sine 30. Substitute, and you calculate it. It will be 500. It will be this answer. It is 5480. Okay. It's 5, this one must be 5480. Okay, so this was for sure not the last version we have given to students. So it's 5480. It's answer A. Again, for a pressure difference PA minus PB equals 8000 Pascal, he gave us the pressure difference. He said the difference H in the height of the oil column in the U-tube is equal to, I have to find the difference in the U-tube column. هلا هيدا لما يكون اليوتيوب من فوق أنا حليت مثله. You take 2 points M and N بقلب الأويل, and then you try to find a relation between them, relate these 2 points to A and B. Anyway, السؤال اللي أنا حليته أو الإكزامبل اللي أنا حليته بالشرح كان A will be at the same level. Here A and B, they are not at the same level, so I have to take this into account. So let's solve as we always do. I will take 2 points as we always do. I will take point M and N at the same level. This is N, at the same level. I will say PM has the same pressure as N. I will erase everything. So let me define the heights between points because I will need them. So this is the first level, so I will elongate this one حتى نميز الهايتس. So المسافة من هون لهون already أنا بعرفها هي L sin 30. okay. والمسافة ما بين هون وهون I only care for the heights. okay. I don't have this distance, so I will call it H prime. No problem if we don't have some distance, it will be cancelled when we solve. okay. So let's now try to find PA. PA في فوقها بس مي عند الأم. So عندي roll of water G قد المسافة. المسافة هي عندي L sin 30 plus H prime plus H plus PM لأنه في الأم. هلا بالنسبة للبوينت B في فوقها مي ارتفاع H prime وفي فوقها oil ارتفاع H. So raw water G H prime plus raw oil G H plus PM. I have two equations. I try to equate them and then I find PA minus PB. So let me move down and write what I have said. I will write P of A it's equal to raw water G L sin 30 plus H prime plus H, okay, plus PM. PB it's equal to row of water G H prime plus raw oil G H plus PN. Now either you calculate PM و PN وبتحطوا PM equals PN وبتعملوا PA minus PB أو شو بتعملوا بتنقصوا اثنين equations من بعض. فيكم you take two equations بتنقصوهم من بعض 1 minus 2 بيطلع معكم PA minus PB وال PM مع PN بيروحوا because they are equal. So PA minus PB raw water GH prime رح تروح مع raw water GH prime, so I shouldn't care about it. I will get raw water G L sin 30, okay, plus H minus raw oil G H, okay. Everything else disappears. I will arrange a little bit. I will get raw water minus raw oil GH, okay, plus raw water GL sin 30. Okay, you can see that when we explained that, when we were explaining in the lecture how to find PA minus PB, the 2 points were at the same horizontal level, so ما كان مبين معنا هيدا الترم. كان مبين بس معنا the first term which is in orange. This is the first term. الرولة الكبير ناقص الرولة الصغير GH. So the second term appears because there is a difference in height between the points A and B. So when you solve, don't memorize the formulas. Please take 2 points M and N and try to find a relation with these 2 points. Calculating, you have everything. You have all the given. When you calculate, substitute 4 numbers, you will get H is our PA. Remember, I'm searching for H, so we will get H equals 1.5 meter. My PA minus PB, my everything arranged, so you will get H. So this is H. Okay, complete it on your own. I will solve another problem. Okay, this is a partial of 2017-2018. This is question related to fluid mechanics. You can see that we have a carbon dioxide flowing steadily through a chamber, causing the deposition of mercury in the manometer, which is the U-tube. Here the U-tube that is inserted to measure the pressure difference between 2 points is downward. So I have to take 2 points from the lower side. The chamber has a diameter of 150 millimeter at point A, so I have the area at this point, I have the diameter, and a diameter of 300 millimeter at point B. Taking rho of CO2 1.98 and rho of mercury 13,600 kilogram per meter cube, and the G equals 10 Newton per kilogram. It says determine the difference in heights delta H of the mercury columns in the tube. So he means that it's H. Okay, it's not delta H. So it's H. It's this H that appears, the difference between the two sides of the YouTube manometer. So how to find delta H? بالgiven لا عندي لا PA minus PB ولا عندي ال VA ولا عندي ال VB، ما عندي بس ال areas وعندي ال rows. Okay, so if I look at the figure I can find the difference من الجيومتري اللي هو معطيني اياه. هو معطيني المسافة من هون لهون 10 ملم، ومعطيني هون الهايت الصغير هو 40 ملم and I'm searching for the big height. كرمال الصورة هون صغيرة شوي بس رح احاول ارسمها هون. انا عندي هيدا الميركوري okay like this. هيدي طولها L equals 100 مليمتر. اوكي ده طول هيدي، وعندي انا ارتفاع هون it's 40 مليمتر، وعندي هيدي الانجل هون it's 30 degrees. So the height here for sure it can be found easily. It's L sine 30. So it's called H1. نحن شو بهمنا؟ أنا بهمني هيدا الهايت 1. أنا بهمني الفرق ما بين ال arms of the manometer اللي هو أنا بهمني this difference اللي هو هيدا ال H. Okay, so you can see that this is H1. H is equal to H1 minus H2. So the difference in heights, I will write here, it's H1 minus H2. It's equal to L sine 30 minus, I can keep everything in millimeter, minus 40 millimeter. So L كانت معنا 100 times half minus 40 millimeter. You will get 10 millimeter. So the answer is 10. This is for the first problem. What is the pressure difference PB minus PA if the difference delta H in the height of mercury columns indicated by the U-tube manometer is 5? So here he's giving me the delta H, he's calling it delta H. So delta H is equal to 5 millimeter. He's asking me to find PA and PB. أعطاني الفرق بالpressures المانوميترز وسألني عن PA minus PB. شو بستعمل؟ بستعمل fluid statics. يعني هو معطيني شيء بقلب الستاتيك وسألني عن PA والPB. So I have to relate them this way. باخد نقطتين. Okay, I will take 2 points M and N. باخدهم تحت. Okay, this is M, or I will invert them. I prefer take M here. This is M. This is M, and this is N. These 2 points are at the same level in mercury. Okay, and they have the same pressure. Okay, بتطلع الM من في فوقها والN من في فوقها. وإذا في ارتفاعات مش معرفة أنا بعرفها it will be removed alone. So إذا أنا بتطلع على الM في فوق الM ارتفاع، أنا بيهمني بس heights. So I can like draw like this horizontal lines to make the figure more obvious. So لحد هون في عندي mercury وبيرجع لفوق كله ووتر، بينما الN فوق كله مش ووتر it was CO2، لفوق كله طلوع CO2. So PM, let me write PM. It's equal to شو في فوقها؟ في فوقها ارتفاع H أو دلتا H، في فوقها ارتفاع دلتا H mercury. So it's rho للميركوري G دلتا H. اوكي، بيرجع من بعد هيدول في ارتفاع لحد ال A. I will call them H prime من حد هون لهون، هيدول CO2. So plus rho ل CO2 G H prime plus PA. P للN equals شو في فوق الN؟ في كلهم CO2 لحد ارتفاع لحد البي. طب قد ايه الارتفاع بيناتهم؟ في h plus h prime. اوكي سو رو CO2 G دلتا h plus h prime. اتس دلتا h بس هو على الصورة حاططها h. اوكي اتس دلتا h كاتبها بالاسئلة دلتا h ورسمها على الصورة اتس h plus PB. وصلنا لعند البي. نحن عنا ال PM equals PN, so equating them you will get PA plus rho HG G delta H plus rho CO2 G H prime equals PB plus rho CO2 G delta H plus H prime. هلا من الجهتين rho CO2 G H prime رح تطير من هون وهيدي من هون. اوكي لانه it's the same. so بيبقى عندي PB minus PA PB minus PA it's equal to what's left. راح اخد هاي لهون rho HG G delta H minus rho CO2 G delta H. so طلعوا هون طلع معي الجواب الرو للثقيل ناقص الرو للخفيف جي دلتا اتش مثل ما نحن حلينا بالشرح. ليه؟ لأنه هون the two points were at the same level so ما طلع معي الترم الزيادة اللي هو خاصه بالارتفاع. Okay? This is the answer. Anyway, you have everything. You have rho, you have delta H is given as 5. So you have to substitute. You will get 680. You will get 680 Pascal. Okay? In part A it says for a pressure difference PB minus PA equals 1360 Pascal. معطيني ال PB minus PA من جديد. Find the speed. So أعطاني ال pressure بيقول لي find the speed. دغري أنا بفكر برنولي. Okay لأنه their speed not بين برنولي. I have to find the speed. Let's apply Bernoulli's equation. So I will write PA plus half rho VA squared plus rho GZA. It's equal to PB plus half rho VB squared plus rho GZB. Anyway, ZA with ZB are equal because they are at the same level. They will be cancelled. So this is ZA and this is ZB. They are cancelled. بدي أنا كمان ال PA minus PB it's given. بيبقى معي بدي أجيب أنا ال VA so أنا بدي أخلص من ال VB. كيف بخلص من ال VB؟ بحاول أعمل relation بستفيد من ال continuity equation. I will write things in not in details because you must have the answers. Okay and there's no enough space so I have to write in short. So using continuity equation معي أنا الاريا على A times VA بتساوي الاريا على ال B times VB. أنا بدي أجيب ال VA so لازم أخلص من ال VB. رح أجيب ال VB in terms of VA. VB is equal to area of A over area of B times VA. هو ما معطيني الاريا معطيني ال diameter so I related to the diameter. It's pi d square A على 4 على pi d square B over 4. أكيد pi على 4 with pi of 4 they will be cancelled. Okay I will write here okay so I will get dA squared over dB squared times VA. هلا صار معي ال VA هاي صار معي ال VB سوري هيدي ال VB رح اخدها وحطها بالايكويشن فوق بصير عندي ايكويشن ما فيها الا بس VA اللي هو القانون اللي انا عم فتش عليه. so I will get PA plus half rho VA squared equals PB minus or plus half rho VB squared اللي هي dA to the power 4 over dB to the power 4 VA square مثل squaring. okay so أنا معي PB minus PA it's equal to half. رح أجمع هيدول لجهة واحدة rho VA squared ورح اخد rho half rho VA squared common 1 minus dA to the 4 over 1 minus dB to the 4. do your calculation on your own. كل واحد مثل ما هو ما بيرتاح على مهله. okay do them and then you have everything. you can find VA squared and then you find VA. I guess it will be equal to 38 meter per second, which is the answer will be B. Okay, this is for this problem. I will move now to do this problem of partial 2015 to 2016. I move down a little bit. Okay, I have to note something that قبل ما كفي انه الرو هون اللي عم نستعملها هي الرو للسي او 2. ليه الرو للسي او 2؟ لانه الفلويد that's flowing between A، انا عم طبق برنولي للفلويد that's flowing between A and B. مين الفلويد that's flowing between A and B؟ it is the CO2 fluid and not the mercury. so الميركوري كان ما خصه بهيدي الستيج between A and B لما انا عم معالج برنولي. اوكي، في عندي انا CO2 gas, so I have to take the row of CO2 as I have indicated. I will try to solve this problem too. I don't have a better copy, but this problem is good to be solved. بقلنا a ball M. So we have a ball here. This is the ball. Okay. M is attached to a vertical axis of a fixed hemisphere by means of a string of length L. So this is a string here. Okay. The ball slides without friction on the surface of the hemisphere, making a uniform circular motion of the in the horizontal plane with a constant angular frequency omega. So the ball is rotating with an angular frequency omega. You can see the trajectory. This is the trajectory of a ball. It's a circle in the horizontal plane. This is the trajectory. عم تبرم على هيمسفير، تخيلوها انتو طابة، اوكي، وعم تبرم على شيء مدور. As the ball is rotating, the string is always tangent to the hemisphere, making an angle alpha equals 30 degrees with the vertical. So tangent to the hemisphere هيدا بيعني انه الزاوية ما بين السترينج وما بين الراديوس تاعول السيركل اللي هي هيدي this is 90 degrees. اللي is tangent to the hemisphere. So the angle between the string the string and the radius, this is the radius of the hemisphere. This is the radius of the hemisphere. So this is 90, and the string is always making an angle 30 with the vertical as shown in the adjacent figure. The question says determine as function of M, G, L and omega the tension in the string and the normal reaction and exerted by the hemisphere on the ball. I have to find the forces acting on the ball, which are the tension and the normal. So to do this, I will try to solve a Newton's second law for circular motion. Remember that each time we have such type of motion, we choose two axes. I will erase this. Okay, I usually choose two axes. One axis بيكون vertical، هيدا Z axis تاعولي، وتاني axis بيكون towards the center of the trajectory circle اللي أنا السيركل اللي عم أبرم عليها. So this is the centripetal axis. هلا بدي أرسم forces acting on my object. عندي weight which is vertically downward. ما تنسوا هيدي الطابة قاعدة من برا على الهيمسفير مثل نص دويرة. Okay, so this is the weight, it's mg. في عندي كمان النورمال لما تكون قاعدة من برا الطابة. So النورمال بيكون لبرا، واتجاه النورمال مثل اتجاه الراديوس تاعول الهيمسفير. لاحظوا النورمال كيف شكله بيجي parallel مع الراديوس تاعول السفير. اوكي، parallel مع الخط اللي انا مديته معه. في عندي كمان التنشن اللي هي لانه مربوط بخيط. اوكي this is tension. ما قال لي بالسؤال انه في عندي friction، قال لي it's a frictionless motion, so no need to do the friction. عندي 3 forces. I will apply Newton's second law. سمنا ال F equals ma. Projection along vertical equals 0. Projection along centripetal equals ma normal, which is mv square على r or m r omega squared. So let me apply Newton's second law. Apply sum of F is equal to ma. We will get n plus t plus mg it's equal to ma. تعالوا نشوف مين في عندي على النورمال. anyway let's start with the angles. إذا هيدي الزاوية 30 I will write with pink. إذا هيدي الزاوية is 30 so this is I guess it's okay. This angle here is also 30. Okay, this angle here is 30 degrees. I guess it's not clear enough, so I will erase this. So this angle here is 30 alternating. Okay, so this is 30. بالنسبة ل الزاوية هون this angle here between tension إذا بدكم والcentripetal هي 60 لأنه الانجل ما this is 90 degrees so anyway we don't need it. أنا بهمني كمان الزاوية ما بين النورمال مع الواي axis. أكيد بما أنه string is tangent to the hemisphere so the angle here is 90 as I have already said. هاي الزاوية هون 90 فإجباري هاي الزاوية تكون من تاني جهة 90. Okay, so this angle here is 60 and angle here is 30. You have to imagine it. Okay, take your time to draw it on a bigger size and try to imagine it. هي الزاوية هون ما بين ال N والstring هي 90. ليه؟ لأنه string is tangent to the hemisphere وال N بتكون perpendicular مع الهيمسفير لأن هي النورمال تاعول فبتجي perpendicular مع الهيمسفير بينما string هو tangent so الانجل between N وstring هي 90 بينما اوكي 90 so انا بيهمني الزاويه مع الزد اذا هي مع التانجنت هي 90 so مع في 30 ما بين الزد والسترينج so يبقى عندي 60 ما بين الان والزد اكسس و30 مع السنتريبيتال اكسس. اوكي this is for the angles. so انا شو راح اقول؟ راح امحي everything. أنا عندي الألفا equals 30 so this one is alpha. هيدي ألفا. أوكي ألفا مع البوينت 90 البوينت مع الألفا كمان 90 أو إذا بدكم فيني أسميها البوينت مع الإكس كمان 90. هيدي الإكس اللي هون ألفا مع البوينت 90 لأنه الأن تانجنت مع الأن 90 degrees مع السترينج. البوينت 90 مع الإكس الانجل ليه؟ لأنه عنا رايت ترينجل بالسيستم تاعولنا سو إجباري الألفا الإكس تكون هي ألفا. أنا شو بعمل؟ بقول I will say here x is equal to alpha so this angle here is alpha which is 30. I don't care for other angles so this is my angle. هلا فيكم تعملوهم 30 و 60 ما عندي مشكلة أنا بس إنه this way we keep only one variable which is alpha. Let's try to project. مين في عندي على الان في على الفيرتيكال في عندي شقفة من الان على الفيرتيكال اللي هي ان لفوق تطلع ان ساين الفا upward. في عندي شقفة من التنشن كمان شقفة التنشن هي لفوق so plus t cosine الفا. كيف بعرف اذا ساين او كوساين؟ الكومبوننت اللي بيكون حد الالفا بيكون كوساين الكومبوننت اللي مش حد الالفا بيكون ساين. so اذا انا بعمل projection للان هي منا حد الالفا along z axis منا حد الالفا so it's sine بينما التنشن حد الالفا البروجكشن تاعه على الزد رح يطلع معي كوساين. في عندي minus mg it's equal to 0. هيدي the first equation projecting along the z axis. كل شيء على z axis بيساوي صفر. n is unknown t is unknown so I need another equation to find them. Projecting along the centripetal كل شيء لجوا بيكون plus كل شيء لبرا بيكون minus so لجوا في عندي شقفة من التي في عندي t sin alpha sin alpha minus n cosine alpha. ليه minus n؟ لأنه الان لبرا صار projection للان along the centripetal is outside الام جي كلها على الزد so no need to project it. This is equal to كل شيء على السنتريبيتال بيكون بيساوي m a normal which is m v square over r والr هي مش الراديوس للهيمسفير هي راديوس للتراجكتوري. فيني اكتبها بهالطريقة ال v بتساوي r omega so it will give me m r omega squared. Okay, صار معي two equations and two unknowns. I have to merge them and get t and m. This is equation 1 and this is equation 2. I have to merge them together to get the answer. Okay, so من أول equation we will get from equation 1 we will get, I will write n. هلا sin alpha هي 30, sin 30 it's equal to half n over 2, so n over 2 plus t cosine 30 it's equal to radical 3 over 2 equals mg. This is the first equation, and the second equation will give me equation 2 implies it will give me رح احط الان حد الان, so minus, I will keep it like as it is, n t over 2 minus n cosine it's radical 3 over 2 it's equal to mr omega squared. راح اجيب الان من اول equation. I will get n it's equal to 2 mg minus t radical 3. okay, this is n. باخد الان هلا وبحطها بتاني equation, so I will get t over 2 minus 2 mg minus t radical 3 كلها multiplied by radical 3 over 2 equals mr omega square. Arrange, let me arrange, so I will get t over 2 عندي minus radical 3 mg plus t 3 over 2. okay, it's equal to mr omega squared. Each one does his calculation as he knows. so عندي half plus 3 over 2 we have 2t it's equal to radical 3 mg plus mr omega squared. so I will get t equals radical 3 mg plus mr omega squared over 2. هلا بعد في عندي شغله هو ما بده كان فيها small r, بده فيها l, which is I guess he wanted l which is the length of the cord. so أنا لازم بدل r ب l. let me go back to my figure. okay, إذا شايفين في علاقة ما بين ال l وال r, هاي عندي مثل شكل right triangle. this right triangle I will color it with something. I won't color it خلاص عشان ما تصير الرسمة بشعة. بس anyway this is r which is the radius here. you can see that sine 30 it's equal to r over l, so sine 30 equals r over l, so it's obvious that r it's equal to l sine 30. I can replace, so r equals l sine 30. I can replace r with l over 2. so here I can replace it. it's equal to radical 3 mg plus m l over 2 omega squared, all of it over 2. this is the tension. هلا صار معي التنشن. I can substitute to find n. I won't do it, so you can do it on your own. so this is the solution of this problem. I will do now problem 3 in the same exam. It says in the adjacent figure water flows from left to right in the horizontal pipe with a speed v1 equals 1 meter per second and leaves from the inclined pipe length L equals 20 centimeter and angle 30. If water exits to open air from point 2 such that cross-sectional area at 1 is twice that at 2, i.e. S1 equals 2 S2, determine height, the difference in the height of the mercury columns in the U-tube manometer connected to the horizontal pipe where the left hand end of the manometer is open to air. See figure. So we have raw water, raw mercury, and P atmosphere. It's 10 to the power 5. So here we have a U-tube in the down, okay, the lower part of the tube, and this U-tube is connected from one side to point 1 and it's open to air to the other side. So let's deal with this one and try to find the answers. You'll see it's similar to others, but okay, it's just a different shape. So what we are searching for, we are searching determine the difference h. We are searching for the difference H in the heights of the manometer. What's given? The speed. So using the speed, I have to relate the speed to P1, P2, then relate the pressure, to the height between the two sides of the manometer. Let me start applying Bernoulli's equation between 1 and 2 in order to find the pressures between P1 and P2, or at least find the pressure P1. So apply Bernoulli. I will do it rapidly. Bernoulli between 1 and 2, we will get P1, I will write it down, it's P1 plus half rho V1 squared plus rho G Z1 equals P2 plus half rho G plus half rho V2 squared plus rho G Z2. اوكي، كلكم تعرفوا صرتوا انه انا راح اخذ الZ1 راح اخذ الريفرنس هون. اوكي، so I will take Z1 is equal to 0. Z2 هي الارتفاع تاعولا. اوكي، Z2 is 4.2 معي ال ومعي الانجل. So Z2 هون I will write it aside. So Z2 it's equal to L sine theta, which is L sine 30. Okay, so we have Z1, Z2, P2 it's P atmospheric, ومع ال P1 I'm searching for P1 لحتى استعملها بالمانوميتر تحت اقدر الاقي ال H. So what do we have still? I have V1 بس ما معي ال V2. I can relate V1 and V2 using continuity equation. So أنا معي I will use my pen. معي S1 V1 equals S2 V2. هو معطيني انه ال S1 equals to S2, so I will substitute 2S2 V1 it's equal to S2 V2, S2 with S2 cancelled, implies V2 it's equal to 2 V1. Okay, so I've got V2 وال V1 صار معي والمعيها اساسا. هلا صار فيني اعوض بال continuity equation. Here I P1 plus half rho V1 squared, قلنا Z1 is 0, it's equal to P2 it's P atmospheric plus half rho V2 it's 2 V1. You can directly substitute for the answer, it's okay, plus rho G L sine theta. Okay, you have everything, so we get P1 it's equal to P atmospheric plus half rho, and the 4 V1 squared minus 1 squared, so I will get 3 V1 squared like this. 4 minus 1, it's 3 V1 squared, sorry, without the bracket. 3 V1 squared, and what's left is plus rho GL sine theta. You have everything, you can calculate P1, you will get P1 equals 102500 Pascal. So this is the answer. بعد ما تلاقوا الانسر now you have your pressure, you will use بتنقوا نقطتين بالمانوميتر هني M and N, 2 points at the same level in mercury. Okay, I will take 2 points. This is point M and this is point N. Okay, I will relate, I will see what's above M and what's above N for sure. أنا معي المسافة من الهون من above M في عندي rho GH لميركوري وبعدين P atmospheric. بالنسبة للN في فوقها ارتفاع اللي هو ال H1 water, so no need to call anything unknown. So we've got okay PM was equal to P, or let me write rho للميركوري GH plus P atmospheric, and P للN was equal to rho للwater. I guess, let me just remember, it was okay, so it was rho of water G, it was called H1 the whole distance plus PA or P1 point called 1. So now P1 equals PM equals PM, it's equal to Pn. Equating them, you will find H. So you will get P1 plus rho omega GH1 equals rho Hg G times H plus P atmospheric. Substitute for P1, its value, everything, you have it. You have H1 is given in the problem, it's given on the figure, it's 15 centimeters. Substitute everything and you shall get your answer. We're searching for H. Okay, H will be 0.29 meter, and this is the answer. Okay, this is the last problem I'm going to solve for today. It's a partial exam 2019-2020. So in this problem it says a block of mass M is placed inside a cone which is rotating around its vertical axis OZ with a constant speed V. The block as a result describes a circle of radius r equals 1 meter in a horizontal plane. As the block M rotates inside the cone, it remains the same level due to the maximum static friction between the block and the cone's surface. The coefficient of static friction is μs, it's equal to 0.5, and the half angle of the vertex of the cone is alpha equals 30 degrees. In this problem it says the motion of the block M is described as, this motion is a uniform circular motion. So uniform, it's U, Cm. Why? Because it's moving in a circle with a constant speed. Okay, if it's moving in a circle with a constant speed, then it is a uniform circular motion. In the second part it says the projection component of the friction force along the vertical axis OZ is equal to, if I'm projecting along Z axis the frictional force, how to draw the frictional force? If the block is to slide, it may slide downwards, so the friction is drawn this way. دايما الفريكشن حسب السبورت بتكون perpendicular مع الان. so هلا هيدا البلوك من جوا، so الان هيك بدها تكون، الان بتكون perpendicular مع السبورت. الاف ار is always perpendicular مع الان مع السبورت. So this is FR or FS if you like. It's static friction. هلا بس بنبه لشغله، ليه static friction مش dynamic friction؟ لأنه البلوك قاعد على الكون والكون هو اللي عم يبرم بكونستانت سبيد. يعني البلوك مش عم يزحط على الكون من جوا، هو هديان على الكون والكون هو اللي عم يفتل. So بالنسبة لإلي ما عم يصير فيه هيدا الاحتكاك اللي بيعمل kinetic friction ما بين البلوك وما بين البلوك وما بين الكون. هو ما في احتكاك، هو at rest على البلوك. بقلي the block is placed inside a cone which is rotating. The block as a result describes a circle. نتيجة الموشن للكون عم يبرم البلوك معه، والبلوك هديان على الكون. لأنه الكون عم يبرم بسيركل، so صار البلوك عم يبرم معه بسيركل. اوكي، كرمال هيك اسمها static friction. It's not rubbing between each other. They are not rubbing each other. They are not moving with respect to each other. Okay, they are moving together. بقلنا ال FS بدو along the vertical, so I have to determine the angle. So, up. Okay, I have to determine the angle. أنا شو معي given؟ معي given الانجل الوحيدة هي هيدي ألفا. Okay, so هيدي الألفا هي نفس الانجل هون ألفا. You can see they are corresponding. This is alpha is equal to this alpha. So إذا أنا بدي أعمل projectional FS along Z axis, I will get I will write down. So I will get Fs along z-axis, it's equal to Fs cosine alpha. Okay, دايما Fs max, remember that Fs max it's equal to mu s n cosine alpha. This is a formula. So this is the answer. It's A. Here the answer is uniform circular motion at speed. Then let me move to D. The projection of the normal reaction force and exerted by the surface of the cone on the block M along the centripetal normal direction UN, it's equal to projection of N على السنتريبيتال. تعالوا نشوف the projection of N على السنتريبيتال أو النورمال. طيب هيدي الزاوية or this angle here is alpha. هيدي الانجل here, this angle I will color it in, I will write it in another color. This one here, it's 90 minus alpha. Okay, لأنه الفريكشن مع النورمال بيعملوا 90 degrees. So شو بيبقى عندي أنا؟ I will choose another color. Not indigo. Okay, this one. So this angle here, this must be alpha. ليه؟ لأنه دايما الزد والسنتريبيتال في 90 درجة بيناتهم. So this angle here is 90. هذه الزاوية ما بين الزد والسنتريبيتال. So this one is alpha. إذا أنا بدي أجيب ال n component, it will be simply along centripetal. The projection لل n will be n cosine alpha. So it's n cosine alpha. So this is the answer. In part 7, the speed of the block of M is equal to find the speed of the block, I have to apply Newton's second law. Okay, I have to find the forces and then try to find the speed. Let me check the forces acting on my block and the normal and the friction, but I have to draw the weight. The weight is vertically downward. Okay, this is mg. These are the forces acting on it. So now I can apply Newton's second law. Sum del F equals ma. So عندي n plus F static plus mg is equal to ma. Projection. So we will get مين في عندي على السنتريبيتال؟ قلنا في عنا الان كوساين الفا. رجعوا شوفوا الرسمه، في عنا شقفه من الان وفي عندي شقفه من الفريكشن بس هي ماينس، so it's opposite للسنتريبيتال. ماينس اف اس ساين الفا. these are equal to m v square على r او m a n، بس انا معي v given so كتبت m v square على r، او sorry I'm searching for v so كتبت m v square على r. Projection along the z-axis في عندي شقفة من الفريكشن upward it will be fs cosine alpha، وفي عندي n sin alpha، في عندي minus mg نزول it's equal to 0. okay هلا let me call this one, let me call this equation 2. From equation 2 we will get Fs is equal to mu s n cosine alpha plus n sin alpha, it's equal to mg, implies n is equal to mg over mu s cosine alpha plus sin alpha. وهيك بنكون لقينا الان لقيناها. هلا صار فينا نحطها بالايكويشن الثانيه. So using equation 1 we will get n cosine alpha minus الاف اس رح اعوضها بميو اس ان sin alpha it's equal to m v square على r. هلا شو بعمل؟ باخد الان كومون وبرجع بعوض محل الان القيمه اللي طلعتها فوق. so n into cosine alpha minus mu s sine alpha equals mv square على r. So I'll substitute for n. I will get mg over mu s cosine alpha plus sine alpha times cosine alpha minus mu s sine alpha. It's equal to mv square على r. M with m, as you can see, it's cancelled. Everything rest is given. Mu s is given to 0.5, alpha it's 30, r was given to 1, so you have everything. You'll get your v, it's 2.57 meter per second, and this is the answer. اوكي هلا كيف عرفت انا انه بدي اروح بهالطريقه؟ لانه هو معطيني الميو اس بالسؤال ومعطيني الراديوس. So I think about using the forces, which is the only way to find the speed in this way. Okay, because I have nothing else that helps me to find the speed other than using the projection of vectors.